Okay, so for here we're recalling our product of power rules. So we're going to start off first by working with just the number component. So our number component, we've got a -5 and we've got a 3 to the 5th power. Now they're not the same bases, but they are just number values, so we can actually work that out. We can go ahead and do -5 times 3 to the 5th. Now the first thing that we want to do is simplify 3 to the 5th, and 3 to the 5th power is just going to come out to 243. Right? It's 3 times 3 times 3 times 3 times 3. That comes out to 243. And then we can go ahead and do -5 times 243, and that's going to come out to a -1,215. Then we can start working on the variable components. So we have x to the 3rd power multiplied by x, which doesn't have a power written, and what exists if the power is not written there? What is it then? A 1, right? So we've got x to the 3rd times x to the 1st, and what we're really just doing is taking those exponents and adding them together, so that comes out to x to the 4th power. Then we go to the y's. We have y to the 7th and then y, which is going to be y to the 1st. So y to the 7th times y to the 1st is the problem we're looking at. All we're going to do is add those exponents together, and 7 plus 1 gives us 8, so we get y to the 8th power. And then lastly, we've got our value of z. Now there's no z over here, but we do still have a z to the 5th on the other side, and that's just going to come straight down into the answer. So z to the 5th. So then we just put it all together, piece it all together, and our final answer is -1,215, x to the 4th, y to the 8th, z to the 5th. That's our final answer. Okay. For problem number 2, we have a fraction, and the fraction happens to be inside of parentheses. So that means that the fraction, the whole entire fraction is getting that exponent of a 2. Okay, so we have 3/4 raised to the 2nd power, and then we have 2 raised to the 5th power. So we're going to work those out individually first. 3/4 to the 2nd times 2 to the 5th. 3/4 to the 2nd power is the same thing as saying 3 times 3 over 4 times 4, which is going to be 9 over 16. And then 2 to the 5th power is going to be 32. And then we can go ahead and multiply 9 over 16 times 32, and that's going to come out to 18. Okay, now we focus on the variables. We have x to the 8th and then just an x. So what we're going to do is we're going to add the exponents, the 8 and the 1 together. 8 plus 1 is going to give us 9. So we get x to the 9th power. Okay, then we have y to the 4th and then y. So y to the 4th times y to the 1st. We're going to add 4 and 1 together, and that gives us y to the 5th power. And then we have a single z all on its lonesome, and it just comes down as a z. Okay, so when we piece it all together, our final answer is 18 x to the 9th, y to the 5th, z. And again, you don't have to write the exponent. You don't have to put z to the 1st. You just put z. Okay, so those are our product of power rules. 3 and 4 are focusing on the quotient of powers. Quotient of powers. So we're first going to focus on the numbers. We have 2 to the 6th over 4 to the 2nd. So 2 to the 6th over 4 to the 2nd. 2 to the 6th is just going to come out to 64. And then 4 to the second is just going to come out to 16. And 64 over 16 can be simplified. It's simplified to a value of 4. Or 4 over 1. You don't know whether it's going to have any fractions yet or not, but just a 4. Okay? Then we go to our variables. We have a to the 9th and a to the 8th. A to the 9th over a to the 8th means that we're just subtracting our exponents. We're going to take the 9 and subtract the 8, and that's going to leave us a to the first, or just a. Then we have d to the 8th and d to the 4th. So what we're going to do is subtract those exponents. That means we're going to really be doing d to the 8 minus 4 power. And 8 minus 4 is 4, so we get d to the 4th. So our final answer here is 4a d to the 4th. Problem number 4, we have 48 over 6. And 48 over 6 can be simplified to 8. 48 over 6 can be simplified to 8. And we have x to the 7th over x. X to the 7th over x means that we are just taking the 7 and subtracting a 1. That comes out to x to the 6th. Then we have y to the 3rd over y. So we're just subtracting 3 minus 1 for our exponents. That comes out to y to the 2nd power. And there's our final answer. 8 x to the 6th, y to the 2nd. Okay. Any questions on these reminders? All right, so let's go on to our next rule. Go ahead and flip it on over to the back. And here I've got 4 to the 2nd inside parentheses, and then on the outside I have another exponent. So for here I have a single base with multiple exponents that it's occurring. See, previously we were working with multiples of the same base that each had their own individual exponent. So we knew that, hey, if we have 4 to the 2nd and 4 to the 3rd, and we're multiplying those, then we just added the exponents, we kept the base. If it was division, so if we had 4 to the 5th divided by 4 to the 3rd, then we subtracted the exponents and we kept the base. But here, you don't have multiples of the same base. You just have one base. But that one base has more than one exponent. So if we were to go ahead and write that out, it would look like 4 to the 2nd times 4 to the 2nd times 4 to the 2nd. Right? We're taking this value, 4 to the 2nd, and we're raising it to the 3rd power. So it's repeating. This 4 to the 2nd happens to be our base, and that base is repeating 3 times. But based off of the product of powers, we know that we can just add those exponents. We can just do 2 plus 2 plus 2, and that's going to come out to 4 to the 6th power. And the same thing here for the y's. We have y to the 3rd. That whole entire power is being raised to the 4th power. So essentially it looks like y to the 3rd times y to the 3rd times y to the 3rd times y to the 3rd. Or we could just add all of those exponents together. That would be 3 plus 3 plus 3 plus 3, which comes out to y to the 12th. But obviously we don't need to sit here and write this out. There is a simpler method to going about it, which would be the rule. Go ahead and talk with your neighbors and see if you guys can figure out what's the rule when you have a single base raised with multiple exponents. Ray, Dylan, heads up. Wake up. All right, who wants to share with the class what rule did you come up with? Hemina? You just multiply the exponents. Do we do anything different to the base? Does the base change at all? No, the base stays the same, right? So when you've got a single base raised to more than one power, so you have a power and then in parentheses another power and then maybe parentheses, it could be a third power, fourth power, fifth power, multiple levels of powers for that single base, then all you are doing is multiplying the exponents together and keeping the base. Let's go ahead and write that rule down. When a base has multiple exponents, you keep the base and multiply the exponents. Okay? If a base has more than one exponent, you keep the base as it is and you multiply the exponents. Then simplify as you can. So obviously 4 to the 6, we could actually simplify that. Now, flashcards. Those of you who will be making your flashcards, because you do need to make sure you memorize the rules. It's called a power of powers. When you have a single power raised to another power, right? Y to the third is a power, and it's raised to another exponent, which means it's raised to another power. So this rule is called power of powers, and it looks like the following. If you've got x to the m raised to the nth power, then on the back of your card, you should be writing that you would be just taking x and multiplying the m and the n together for your exponent. So again, it's called power of powers. X to the m to the nth power means you're just multiplying those exponents together. All right, so let's take a look at some of these examples. We want to go ahead and simplify as far as we possibly can. So if we have 3 to the second raised to the third power, then all we're doing is keeping that base and multiplying these exponents. 2 times 3. What's 2 times 3? 6. So we get 3 to the 6th power. But it is a numerical value. We can go ahead and simplify it all the way. What will 3 to the 6th power give us, Armando? Very good. 729. Okay. Problem number 2. Here we've got the Greek value pi. So we'll just leave it as Greek terms. We'll leave it as pi. But pi is raised to the 5th power, and then it's raised to the 3rd, and then raised to another power of 2. So it has more than just 2 exponents, and now it has 3 exponents. So again, we're taking that value of pi, and we're multiplying the exponents together. 5 times 3 times 2. And what is 5 times 3 times 2? 30. So we get pi to the 30th power. Go ahead and do problem 3 on your own. Do not do 4, 5, or 6 yet. I'm going to show you how to do number 4, 5, and 6 in a little bit. All right, who got number 3? Maya?
The answer?
Yeah.
M
M to
to the 9th power.
the 9th power. All we're going to be doing here is taking our value of m, and the exponents are going to be 3 times 3. And 3 times 3 is just going to give us 9. So we get m to the 9th power. Okay, now for problem number 4, we have more than one base, but we still have parentheses around that entire clustering of powers and it's all raised to the sixth power. So again, you're going to split this up into separate problems, but what you're going to do is you're going to take this exponent, this 6, and you're going to distribute it as multiplication. So that 6 gets distributed to the first base, which is that -2. Then it gets distributed to the second power, which was a to the 6. And then we also distribute that 6 to the third power that we see here, which happens to be b to the 7th. So you're splitting this up, you're creating it to be several different problems within a problem. So let's start with the numbers first. We've got -2, which currently is being raised to the first power. And what we want to do is we want to go ahead and raise it, and here we'll put the blue brackets around it, to the 6th power. Now notice I put -2 in parentheses because right now there's only one value of -2. So that means that base itself is having that 6 distributed to it. So I have to include the negative sign. So I have to put parentheses around it. So all we're doing here is we're taking -2 and we're multiplying 1 times 6. And that's going to come out to -2 to the 6th power. And we can simplify. We can actually do -2 to the 6th power. What is -2 to the 6th power going to give us? Alex? Not -64. You had to put parentheses around that -2. So positive 64. Be mindful, guys, that if you don't put parentheses, and here I'll show you, he probably, I'm guessing you typed it into the calculator like this. Yeah? So when you do that, it's going to come out to a -64, but you have to include the parentheses around the -2, and then you can put the 6 on the outside, and that comes out to a positive 64. That's going to change your answers. That negative sign will throw you off and change your answer. You will get it wrong, so be mindful. This is going to come out to a positive 64. Okay, now let's look at the a. We've got a to the 6th, and we're going to go ahead and multiply it by a 6, right? Because this essentially looks like a to the 6th raised to the 6th power. A to the 6th raised to the 6th power means we're just multiplying 6 times 6, which comes out to a to the 36. Then we've got the b. B to the 7th is being raised to the 6th power. So we're just going to take that exponent of a 7 and multiply it by the 6, and that comes out to b to the 42nd power. So if you were to write it all together, you would have 64, a to the 36th, b to the 42nd. A to the 36th and b to the 42nd. I want you to try number 5 and number 6 on your own. Try number 5 and number 6. All right, who can tell me what they got for problem number 5? Yochan? Very good. Okay, so we get 625 r to the 16th, x to the 40th. Okay, so what we're doing, again, we're splitting this up. We have our numbers here. This is 5. That's technically raised to the first power. And we're going to take this 4 on the outside and distribute it to there. So we're doing 5 to the first raised to the 4th. That means we're going to do 5 to the 1 times 4 power. Go ahead. Okay, 1 times 4 gives us 4, and then 5 to the 4th can be simplified to 625. Okay, then we go on to our r to the 4th. So we have r to the 4th that is also being raised to another power of 4. So all we're going to do is multiply those exponents. We're going to do 4 times 4, and that comes out to r to the 16th power. All right, then we do the same thing for x to the 10th. We have x to the 10th that is now being raised to the 4th power, because again, we are distributing those powers. Okay, we are distributing that 4 to each of the powers, or to each of the exponents. Okay, so this becomes x to the 10 times 4 power, and then that's going to be x to the 40th. Okay, so the whole thing pieced together, if you need to see it in just a single color, it's 625 r to the 16th, x to the 40th. All right, what about for problem number 6? I know that's a lengthy number value there, but what did you get, Bridget? Very good, yes. So for here, we've got 7 to the 2nd that is now going to have that exponent of a 4 distributed to it. So we're doing 7 to the 2nd power raised to the 4th power. So we're just going to multiply those exponents, 2 times 4, and that comes out to 8. So you now have 7 to the 8th power. But we can go ahead and simplify or evaluate 7 to the 8th all of the way. And that comes out to 5,764,801. Yes. Okay. Then we've got a to the 5th that's going to have that power 4 distributed to it. So a to the 5th power raised to the 4th power means we're just going to multiply those exponents. We're going to do 5 times the 4. And that's going to come out to a to the 20th. And then for our last one, we've got b to the 6th. B to the 6th is also going to be raised to the 4th power. So we're just going to multiply those exponents together. That's going to become b to the 6 times 4 power. And 6 times 4 is 24. So you get b to the 24th power. Okay, so again, it's a lot of rules. It's a whole lot of rules to remember. But if you can get those rules memorized, it's a very simple process. Now, I do have an assignment for you through Delta Math today. So go ahead and get onto Google Classroom, and you're going to complete the Delta Math assignment. You are going to have a quiz tomorrow on these first few rules. So you might want to make those flashcards to memorize them. Yeah, where's your computer? Oh, okay.
I just forgot I had a computer.